Hello, and thank you for inviting me for the Teach eConference 2024. My name is John Hartman. I'm at the University of California, Santa Barbara. What I'm going to talk about today is something that has been quite problematic for me and a lot of other people in recent years. We teach classes with large numbers of students, but we have a very difficult time trying to get small group work as part of the day-to-day activities that they're doing. So what I've done is I was presented with the opportunity to teach introductory probability and statistics about 3 years ago. And so what I've done is I have recreated the way that we teach this class. We no longer have the standard format of 3 lecture hours per week and 2 hours of discussion section. We've completely reformulated the class, and so I'm going to present to you today how this has been done. So as we know, again, learning in large lectures, there's a lot of talking from instructors, a lot of students listening. This is just your standard passive learning type course. Meaningful, active, and cooperative learning, this has been much more difficult to do in very large lectures. Some people have been able to make it work, but it's much more difficult than if you have a smaller class size. So this led me to believe, well, how do I get a smaller class size despite having a very large number of students? We know that cooperative and active learning can be very beneficial to students. In recent decades, there have been many people that have advocated for it. This is a small listing of the literature that's out there. The first one is actually my introduction to active learning. I was a TA in 2001 in a Principles of Economics class using the Bergstrom and Miller textbook that uses actual experiments. And so this has helped to inspire me in thinking about, well, how can I get more active learning in the classes that I teach today? So here's what I had to deal with. Is it possible to have an introductory statistics class with a small class size, with a significant amount of active learning, with annual enrollments well over 1,000 students? In fact, 1,200 students is pretty normal for what I have to work with. Also, I'm the only faculty member involved in teaching this class. So you may say, well, this seems impossible. How do I make the numbers add up? Well, let's see how we do this. So the first thing is we have to determine the number of classes that we need per year. So we need at least 25 in the case that I'm working with. Well, it's going to be very difficult because I can't teach 25 classes per year. So the first thing that I've done is that I realized that I can't meet with each class for 3 hours per week. And so what I've done here is that I make 3 classes count for 1 teaching credit. But the way I do this then is I meet with each group only for 1 hour a week. The second hour is through asynchronous videos where it has a lot of lecture material. This is something that students can do on their own. The third class hour is a common hour for all the classes taught in a quarter. So for instance, in a typical fall quarter we'll have 12 classes, and 1 hour per week will be in a large lecture hall that holds 860 people. So well, large enough so that we're able to get everybody in that single class. Well, here we do things on scale that we're able to do. We have an introductory meeting at the beginning of the quarter. We do review sessions in there. We also give the midterm. This also has the advantage that we can give the same midterm to all students, and so we don't have to write a whole bunch of different tests, just a single test for everybody at the same time. But I still need help because even if I were to teach 3 classes in the fall, 3 classes in the winter, 3 classes in the spring, I still need more people to teach this course. And so this is where graduate student instructors come in. In fact, in a typical year, about 80% of students are taught by a graduate student instructor. I also use undergraduates. We have a lot of eager undergraduate students just waiting to have the opportunity to help out teaching a class. These students will help students in part of their class time, and they also do grading of weekly activities and assignments in cases where we think that undergraduates have the ability to be able to do this. So what does the course structure look like? So remember, the old course structure had 3 lecture hours per week, large lecture hall, 2 discussion section hours per week. So that's the old structure that we've seen. In this circumstance, when it was taught by a different department, the class size was usually between 300 and 350 students. Here, our new structure has a typical class size of only 40 to 50 students. And so we have that one lecture hour per week that they do activities. We have that asynchronous hour for watching videos. We have a common hour each week. And then we've also redesigned how we do discussion sections. One standard discussion section hour where problem solving takes place. But the second hour, we've discovered that students often are lacking in skills for Excel. And so we decided that we will have one section hour per week devoted to learning Excel. Here, though, we pool 3 different sections into one, and we have a teaching assistant, a TA, working with an undergraduate assistant to be able to reach as many students as possible during that class hour. So where does the activity take place? Well, it's going to be in one of these types of classrooms. So here at UCSB, this is what's commonly referred to as a project-based learning room. You might just call it an active learning classroom. This is what a lot of people would think of a room here where we're fostering students to work together in small groups. Activities can be done in a regular classroom. I've done it before, and I've done it very successfully. The only significant downside I've seen is that it's a bit slower to get groups together. Here you just ask students when they show up to sit at a table and sit with the people that they want to work with on a given day. So for the classes I teach, these are all self-chosen groups. You may wonder, well, what types of activities do you do? My favorite is where we talk about discrimination. And so the context that we work on here is that we have discrimination and promotions. I give a hypothetical situation in which in a given year a company gives 17 out of 21 promotions to men. This provides us an opportunity to use the binomial distribution, and we can try to answer some real-life questions. So for instance, if there's a probability of 50% that a man gets a promotion, a 50% chance that a woman gets a promotion in a given year, we see with the binomial distribution that these types of very high percentages going to men is extremely small. Many of the students that go through these activities, they literally tell me they're blown away or state something that they didn't have any idea that this was going to be the outcome that they saw. How does this look in terms of students in action? So this is what a typical group looks like. They sit at a single table working together. We have 4, 5, or 6 students typically. They have the ability to use their laptops. There's a computer at each station if they're in an active learning classroom. They can use their textbook, they can use their notes, whatever it is they want. This gives them an opportunity to try to figure out which techniques work and which ones do not. Here's another group working. And believe it or not, despite what people might believe, it is possible for students to enjoy what they do in the classroom. It is possible to see students smiling. This is what I see on a regular basis. They really appreciate what they're doing if they do statistics and probability rather than just passively watching it. Now, given that there are so many different classes, we need consistency between the classes. So you have a common learning management system page. We use Canvas at UCSB. As I said before, we use common exams each quarter. And we also have a head TA. This TA is almost solely in charge for providing consistent grading standards for all classes, working with other TAs, working with undergraduate students to make sure that everything is well coordinated. We also use a lot of technology. There are auto-graded assignments, which significantly reduces the amount of grading involved. Because of this, we also need fewer TA resources. With the increased use of technology, with the old teaching structure, without this technology used, there was typically one TA per 40 or 50 students. Under this format, we have one TA per 70 to 100 students. Now, this is how this class works, and I have some questions that I've seen based off of students' behavior that I want to pursue in the future. So the one is, does this format work well for all students in the class? For less prepared students, for more prepared students, for both men and women? These are all going to be important questions that I want to ask. Also, as I mentioned before, students currently form their own groups each week. Is this optimal? Or would it be better if they are chosen by the instructor? And if that's the case, what type of characteristics will lead to optimal performance within these types of activities? That's all I have for you now. I hope that this inspires you for some of the classes that you might be teaching in the future. You're always welcome to reach out to contact me if you have any further questions. And if you want, there's a QR code below that I have a web page that gives you more information on this teaching structure, and I also have a sample course syllabus. Thank you for your time, and I hope you have a great conference.
Hello everyone, my name is Jonathan Graves and I'm here from the Vancouver School of Economics to talk a little bit about our work using Jupyter to teach and assess econometrics. So here's my pitch. Imagine this pretty common scenario where you want to show some students some cool patterns in economic data. You want to teach students how to maybe do some coding, or you're trying to demonstrate a new econometric technique or something like that. This is a major learning context that many economics educators face in any course that deals with data or computation. But if you've ever tried to do this, this is way harder than it sort of should be. In particular, your students need computers that can run the material. They need to have the right software. They've got to install that software. They've got to know how to use the software, maybe write code in it. And you also need to have a way to share the learning materials with your students as well. In a classroom setting, all of these are major points where something can go wrong. So in this talk, what I'm going to do is I'm going to introduce you to a solution that we've been exploring at the Vancouver School of Economics, which is using Jupyter notebooks to teach and help students learn applied econometrics. And we do this as part of our open source learning project, which we call COMET, for creating econometric learning materials. Okay, so the overview of the talk today is, first of all, what we're going to do is I'm going to talk a little bit about what are Jupyter notebooks, what are some of the alternatives, and what are the advantages of the Jupyter framework. Following that, I'm going to talk a little bit about how we can use them to teach econometrics. In particular, what is our COMET project, and what are some strategies we've developed for teaching using Jupyter notebooks. And then finally, I'll talk very briefly about how you can use them for assessment in the classroom. So first of all, what is a Jupyter notebook? Or more specifically, what is a notebook in general? Well, a notebook refers to a digital document which combines rich text, such as hyperlinks, mathematical equations, formats, and images, with what are called cells that can perform different kinds of computations. There are many different examples of this, but they include Jupyter notebooks, R Markdown notebooks, or observable or D3.js dashboards. The key feature of a Jupyter notebook is that a user is able to interact with and change the content of a notebook, which dynamically regenerates the output, such as performing a computation or changing the text or editing an equation. For example, here's one of our notebooks that we've used previously in our classes that deals with clustering and classification. And you can see, if you take a look here, feel free to pause the video. You can see it's a combination of equations, of text, of code, and of output from that code. We'll talk a little bit more about this later. So why are notebooks useful for teaching and learning? Well, there's three main reasons. The first reason is that notebooks naturally lead students towards what's called the literate programming framework. This is a popular framework for data science because it creates, in the production of a notebook and in student use, a self-documenting tools that interweaves coding, analysis, and output all together, which helps to address many common problems that novice and experienced researchers face when doing data analysis projects. The second reason is that it helps produce replicable and reproducible economic research. Because notebooks are designed to be run or interacted with from the start to the bottom, this makes it sort of naturally replicable. Students need to follow processes that create replicable and reproductive analyses when they're doing data analysis. And finally, it's industry relevant. In industries that use data science or data scientific tools, notebooks are considered to be the sort of standard industry tool for doing different kinds of a data analysis, which makes it immediately relevant to employment opportunities. So when we take this sort of research and employment-based tool and we turn it into something that we can use for classroom instruction, it also becomes a really valuable pedagogical tool. So what is Jupyter? We've talked a little bit about notebooks so far, but Jupyter, or Project Jupyter, is an open source project that was designed to help support interactive data science and scientific computing. It's associated with a number of different sub-projects, one of which is the Jupyter Notebook itself. But the sort of signature of this framework of the Jupyter project is the use of a central server called a Jupyter Hub, which people connect to, and then it runs kernels that perform different kinds of computations. Now, this is usually used with a server that students connect to remotely, but it can also be installed on their own computer as well. And users interact with the notebooks by editing them and then running cells that contain different kinds of content, which the server processes and then returns the notebook that creates the output. Let's see what this looks like. So in this example here, here's the classification and clustering notebook we looked at earlier. And you can see, if you take a look, there's different areas, the cells of the notebook, that contain different kinds of content. So for example, that rich text content is authored in a language called Markdown, which is very easy to learn. And when you run that cell, it produces something that looks like a pretty good-looking piece of scientific computing text with equations and all sorts of things. You can also do images and hyperlinks and other things like that. However, where Jupyter really shines is with the code. You can see that code cell there. When you execute a code cell, it processes the code and then returns that as output, which is then included into the notebook, which you can see both above and below this particular thing. And that includes, as you can see, visualizations, but also sort of raw outputs such as tables or text and things like that. So why Jupyter as opposed to other kinds of notebook frameworks? Well, Jupyter has some specific advantages for teaching that are not shared by some of the alternatives or aren't completely shared. So the first thing is the use of the Jupyter Hub architecture means that there's no installation necessary when using a Jupyter notebook via the hub. What this means is you don't need to install any software and you don't need a powerful computer. People can basically sit down, log into a website, and they're ready to go. I've had students take part in different kinds of econometric exercises, literally using a tablet or even an iPhone. The second reason is that Jupyter has good GitHub integration. There's an extension called NB Git Puller that allows you to basically provide students with a link that synchronizes notebooks between a GitHub repository and their personal account, which makes it very, very fast to start using notebooks in a classroom environment. The final reason is that Jupyter is language independent. There are computational kernels that actually perform the calculations available for all of the major languages that are used in economics, including R, Stata, Python, and Julia. Okay, but where do you find a Jupyter Hub? That seems like a pretty important problem. Well, there are different options. In particular, there are a number of very good free options available now. If you're part of the Google ecosystem, Google Colab is an excellent free hub option. However, if you also have GitHub accounts, the GitHub Codespaces system now also supports Jupyter Lab as well. Finally, there's an open source system through the Pacific Institute for Mathematical Sciences called Syzygy, which also provides free hubs with just a Google account or if you're associated with one of the affiliate institutions. It's also relatively straightforward if you have a development team and some IT knowledge to set up your own hub or work with nonprofits like 2i2c to develop your own system as well. I will also mention that there are some alternatives. So Jupyter Notebooks are not your only option for teaching. You can use Quarto notebooks if you're interested in offline or multi-format notebook production. You can use R Markdown if you're really just interested in R programming, or if you're interested in dashboarding, you can use Observable or D3.js instead. One of the good things is you don't have to make that decision right now. These formats can be converted back and forth, so you can switch back and forth between different kinds of notebook formats. Okay, so let's talk a little bit about how we can use Jupyter Notebooks in teaching. We've tried using Jupyter Notebooks in many different teaching settings, and we found that it fits most teaching styles. We found them particularly effective in lectures, flipped classrooms, and workshops or labs. However, the way that you use them in these different settings tends to affect the design of the notebooks, which is worth mentioning. So when you're using a notebook, a Jupyter notebook in a lecture or a demonstration, it's best to use them as a sort of demonstration tool. You demonstrate by interacting with the notebook, the students follow along on their own computers. And the power of a Jupyter notebook is that interactive nature of the different cells. By being able to edit them, manipulate them, and change them on the fly, and to show students how you're interacting with them, it allows you to really enrich your lecture content by sort of using them to demonstrate principles, such as shifting a demand curve or changing a variable in a regression analysis. For example, one really effective technique we found that works super well with techniques like iClicker or other kinds of classroom response systems is to demonstrate a cell, explain the principle behind it, and then ask students what would happen if you did a different kind of change. Then do it and ask them a question about this. It naturally leads to the kind of experimentation that leads to really, really strong and long-lasting learning. We've also found Jupyter notebooks work really well in workshops, labs, and flipped classrooms. The interactivity of notebooks makes them really ideal as a kind of pre-reading exercise that you would use in a workshop or for a flipped classroom. By integrating interactive self-tests into the notebook, so situations where the notebook asks them to perform something and then gives them feedback, you can use this both to keep students engaged with the pre-reading and to check their understanding. And if you're using these for assessment, you can also use it to check whether they've completed the notebook or not. When you then bring those notebooks into class, you can have students complete a more elaborate example or maybe perform an application. This has worked in lots of different contexts, and we found this easy even for TAs and other students to self-study or to teach one another. Finally, I'd like to mention a little bit about how you can use Jupyter notebooks for assessment. In the same way that self-tests facilitate study and reflection in flipped classrooms, you can also integrate test functions along with things like hash functions or some other tips and tricks that we have on our website, where you can turn them into good assignments and exams that don't just sort of show students the answers. We've also used them very effectively with custom Jupyter hubs and a lockdown browser to carry out computational exams in a kind of bring your own device framework. What's also great is Jupyter hubs can be set up to both distribute and collect exams, which makes them work really well with things like Chromebook-based computer labs and things like that. If you want to get really sophisticated and you've got some IT support, there are also Jupyter-based assessment systems such as NBGrader or AutoGrader developed at UC Berkeley. So this was a really quick introduction to some of the ways that we've used Jupyter notebooks at the Vancouver School of Economics. But I wanted to mention that all the resources and all of the things that we've developed for our classrooms are free and open source. You can find a copy of the presentation at this link here, and all of the links that are in this presentation are also available on our website, along with all of our materials. If you want to get involved or would like to collaborate more, feel free to send me an email. This is my email address here. And I hope you come and learn more about Jupyter and share and collaborate on some other projects in the future. Thank you.